Okay, in Algebra Chapter 10, Section 7, we're going to talk about this term called the discriminant, which is something that you're already familiar with, but the word itself you might not know. So, can you discriminate? And don't say it, but give me the letter that you see in just 3, 2, and 1.
H.
Now, if you can't, some people actually are what? What is it called? Colorblind. So, this is a test for a person who is that if you are colorblind, you have a genetic difference and you are not able to discriminate between green and red. So I don't know if anybody in here is colorblind, but it's a little test that optometrists or ophthalmologists might give to people to so what does it mean to discriminate? To pick out, Summer says. Or what do you say, Michael? Yeah, to tell the difference. Exactly. So that's what we're doing today. We're picking out or telling the difference. We're not really here to see if you're colorblind. Okay? We're discriminating. And so there's a piece of our quadratic formula that helps us do this. So the piece of the quadratic formula that helps us do this is what is inside the radical.
Did I actually get it right?
Well, it's b squared minus 4ac.
I got part of it right.
What is inside the radical? We can use that to tell the number of solutions of a quadratic equation. Remember, this here is a formula to find solutions for a quadratic equation, which could be graphed. It's a parabola. Okay, so let's think about what is inside of the radical, the discriminant, can help us know the number of x-intercepts, which are solutions. Solutions are x-intercepts. So if I take that whole thing, b squared minus 4ac, and I get 16. If b squared minus 4ac is 16, what is possible, or what is the square root of 16, Michael? Not just 4 though, right? 4 or negative 4. So when we have a b squared minus 4ac that is greater than 0, we have two solutions, which might look like what we see here. We have a parabola that is intersecting the x-axis twice. Now the parabola could be facing up, but either way it's crossing the x-axis twice. What would happen if the b squared minus 4ac equals 0? Jack? One solution. So, because the square root of 0 is just 0, it's only one thing. So you'll end up with a single solution. You would have negative b plus or minus 0. It doesn't matter whether you're adding or subtracting 0. It just gives you one fraction, negative b over 2a. So you do have one place where this parabola is intersecting the x-axis. And so what's our final possibility for the discriminant? So what would that look like in here? I'm hearing people say no solution. A negative, right. What if b squared minus 4ac is negative 1? What's the square root of negative 1? No solution. Can't do it. So we say this particular graph is not touching the x-axis anywhere. It doesn't mean you can't graph it. We've shown that. You may not have a solution, but it's very graphable. It's a parabola that is opening down with a vertex below the x, or we could have a parabola opening up, but the vertex is above the x-axis. Once again, you're doing little graphs so that you show the connection between what you're getting for answers, number answers in a quadratic formula or whatever method you might use, and how this really equals a point on a graph. You're always trying to make that connection that your solutions are actual places on a graph. Okay? Okay, so we are just asking you here, how many solutions does this quadratic equation have? So what is the simple test that a person could use to determine the number of solutions? Selena? We're going to look at the discriminant, right? So tell me, what is in this, the radical? B minus 4AC. This is what we're looking at. We don't even need to show the radical, but I'm going to show it so that you can keep in mind that we're considering taking the square root of this, whatever this expression equals, right? So fill in the information, Selena. What is it for this one? 8 squared minus, okay, and 8 squared is 64, and 4 times 3, 12 times 7, 84. So what is 64 minus 84? Negative 20. So how many solutions? 0. 0 solutions. Good. Can you take the square root of negative 20? No. That's why. Okay, so there is no real number that comes out of this. There's an imaginary number, but not a real. We're dealing with real numbers. Okay, so each time we simply test a discriminant. And who can fill this in for us this time? Talia.
So it's b squared minus 4ac, and then so it's 2 squared minus 4 times 1 times -3.
What is inside there?
-12.
Negative 12. 4 minus negative 12 is actually 4 plus, add the opposite, right? So we have 16. So how many solutions?
1.
Square root of 16 is plus or minus. And how many solutions?
2.
2 solutions. So this is a parabola that will cross the x-axis in 2 places, right? Looks like if we use this equation, it would be opening up, crossing the x-axis in 2 places, okay? And here. Fill it in for us, Michael. Good. And 20 squared is? And then 4 times 25 is 100 times 4. I'm going to this first because 100 is so easy to multiply. Times 4 is good. So how many solutions? Well, you're taking the square root of 0. So how many solutions? 1. So this is a little bit of a tricky spot here. If you can take the square root of 0, there is 1 solution. It is 0, right? Then there is 1 solution for your quadratic equation. The graph of it, tell me what it looks like if it has 1 solution. The graph, it's on, good, it's just touching. The vertex is on the x-axis is what that is. Okay, so how about here? What's the difference here? JD.
So we have the b squared minus 4c. Well, first we're going to want to add the 4x to each side,
Why are you adding 4x to each side?
so that it's in standard form.
Good job. Set it equal to 0 standard form. Perfectly said. Okay, so now you can test it. So if you receive a quadratic equation that's not in standard form, put it in standard form. And then tell me, JD, we're just being asked again how many solutions. So how would you plug it in?
4 squared minus 4 times 1.
So you have
16 minus 16.
we have square root of 0. So how many solutions?
1 solution.
1 solution. Good job. Okay. So this is another question. Can you find the number of x-intercepts? So what's different about this equation? Andrew. It has a y. Good. So if you're asked to find the number of x-intercepts, what will you do with that y? What's the y value for x-intercepts? Every point that's on the x-axis has a y value of? 0. So what will you do with this y? Set it equal to 0. Right. So here again is another way to ask basically the same question. But of course during a test, if you face this question, you're going to have to handle it on your own. When you raise your hand and say, Mrs. Smith, do I set that equal to 0? I have to say it's up to you, you know. It's a test. It's a test to see if you know what this means. Find the number of x-intercepts. And so yes, you do. You do what we've been doing, but you've got to make the connection between an x-intercept and a y value of 0. Okay, so do it. So you may rewrite it. And you're just being asked to find the number again. You don't even have to find the x-intercepts, just the number of x-intercepts. So tell me, Arthur, how would you plug it in?
So, for b, I would put 10.
So you would say 10 squared.
Yes, take away 4 times 1 times 25.
And so what is 10 squared?
100.
And what is 4 times 1 times 25?
That's 0, which is no solution.
There's one solution. Good.
So it means there's one x-intercept.
There's one x-intercept. So again, the vertex is sitting on the x-axis. And it looks like this is opening up. So you have some sort of a parabola that's sitting right on the x-axis. Okay? Number 2 is a little different looking, isn't it? We're used to seeing 3 terms. So what are we doing here, Lauren?
Well, we'll set it equal to 0.
Okay.
And then we'll put it in the radical. So
Okay.
then it would be, I put negative 9 squared minus 4 times 1 times 0.
C is 0. Very good. So she's identified that when you don't see a term out here, you could write plus 0 if you wanted to see something, because that's what's there. So when we multiply that second term by 0, it kind of wipes that whole thing out. And you have negative 9 squared, which is 81, minus 0. So how many solutions?
2.
2 solutions. Okay, good. And pause and come back and check your answer on the final one here. We have to, yes. So here we have no solution. This particular graph opens down and has a vertex below the x-axis. So it's very graphable, but it has no solution, no x-intercept. Okay? There's an interesting example 4 in this section, which shows the Centennial Fountain in Chicago, which I had a chance to see last summer. Has anyone else seen this? It's like a huge fire hydrant type of thing. It's a pump thing, and it pumps water out of the river and onto the river as an artistic thing. So what does it form? What shape? A parabola, right? So once again, they give you the equation, and they ask you to find out whether the water arc reaches a height of 50 feet. So which of the values in this equation are we looking for? X or Y? X is a horizontal distance, it says. Y is the height. So we're looking for Y. So if we're testing this to see if the water arc reaches a height of 50, where would we put it? Y. Good. You just plug it in here. And then you test, find your X, and see if we cross at 50. And if we do, maybe it happens twice, right? If it only happens once, then it just touches 50 and goes down. So you can follow that example in your textbook. So just an example of a real world problem where we could determine whether there's 2 places, 1 place, or no place that it reaches. Okay? Do remember to give your best effort for any real world problems. It's really where it will count for you. Okay? And the quizzes are coming back today.